So when trying to find the surface area of something, we normally just add together all the outer layers. For this cylinder here, we've got three layers. We've got a circle on the top, we've got another one on the bottom, and we've got this last layer that goes right around the outside. So let's start with this top layer here, the circle. Well, what is the distance that goes from the center of that circle to the edge? That's the radius. So we're going to find the area of this layer here first. Well, the area of a circle is pi r squared. We have a second one down here, a second circle, so we're going to add that one on as well. We're going to add another pi r squared. There's our r, it's exactly the same as the top one. Now the third layer is this layer that goes right around this cylinder. Now an easy way to think of it is if this was a can of soup or a can of cat food has a label that runs straight around it. Well, we're just going to cut that label off. So if we just put a dotted line down here, like we're going to cut it off down this dotted line, and we're going to unwrap it off this can. So when you unwrap a label off a can of soup or a can of cat food, it will look something like that. And what shape is that we can see here? It's a rectangle. So we're going to find this area here, the area of this layer. So you just need to ask yourself, well, what is the area of a rectangle? It's simply going to be the base multiplied by the height. There's our height there. So on this cylinder, we need to know what the height is. So I'm going to place height over here as well. And last of all, we need base, because we have area is base times height for the rectangle. So what is the base length here? Well, that's a tricky part. That's the only tricky part of this question. It is the distance that goes right around the outside of this cylinder. So I'm going to start from that point there, this circle right there, and we're just going to trace around this circle. So we're going right around. This is the length of the base of that rectangle we've pulled off. It goes right around, and it goes right through here, and it comes back again and starts where we finish this line, where we finish that line there. So we need to ask ourselves, what is that distance going around a circle? What's that also called? The distance around a circle. That's called the circumference. And we know the circumference formula is C is equal to 2 pi r. So over here I've got B for the base length, but we just figured out that the base length is also known as the circumference for this shape here. So I'm going to just put a cross through the base. We don't want to use B because we don't have B over here. What we've got is 2 pi r. Now we normally say the area of a rectangle, the area is base times height. But are we using base over here? We're not using base. We've got 2 pi r instead. So last of all, we just simply say the area of this rectangle, instead of base, I'm going to say 2 pi r, that's our base, multiplied by the height. So area is 2 pi r times h. That's going right around, that's that whole area there. Okay, so we just need to add it to our little formula that we're making up here because we're adding all the layers together. So we have pi r squared, that is that top circle. We have another pi r squared, that is that bottom circle. And we have one more layer that we have to place, that's that rectangle here, and that is, I'll just put it in the same color, plus that third layer, and that is 2 pi r h. Now another way to think of this whole thing is we'll just say surface area of a cylinder is equal to pi r squared plus pi r squared. Well, if you've got 1 pi r squared, you add another pi r squared, you've got 2 pi r squareds. So surface area is 2 pi r squareds plus, we have to add this, so it's 2 pi r h. There is your formula for the surface area of a cylinder. So let's give it a try. Okay, what we're going to do now is we're going to place some values in. So once again, we've got a point that runs right there from the center, and we go right to the edge, and I'm going to say that that distance is 5 meters. So I'm going to squeeze a 5m in there, 5 meters. Now we're also going to use a height of 8 meters. So I'm going to place 8 over here. It goes from there to there. That's the height of the can, if you want to think of it like that. And now we're going to try to find the surface area. So we're going to add all 3 layers. Well, if you remember the formula we had, surface area is 2 pi r squareds, because we have 2 circles, and then we figured out that the area going right around is 2 pi r h. So let's plug in these values and see what happens. Well, we've got surface area is 2 pi, Now for r squared, I'm just going to put that in a different color. We're grabbing r, our radius is 5 squared, so 2 pi times 5 squared. Then we're going to continue with plus 2 pi, and then we've got another radius, that's 5, so 2 times pi times 5, and we have a height over here which is 8. So I'm just going to put little points there. 2 times 5, 2 times pi times 5 times 8. So we'll just run this through our calculator. What you should get for 2 times pi times 5 squared is 157.08. And you're going to get a few other decimals, but you're not going to clear that. You're just going to hit plus on the calculator, and then you're also going to put in this 2 times pi times 5 times 8, and that's going to give you 251. If you do it separately, you'll get 251.33. But we need to make sure we add all of these together in one calculation, because otherwise you get your rounding errors. We start dropping off these decimals and you don't want to lose those. So our final answer should come to 408.41 meters squared. So that is the amount of surface area on this object. Now I'm just going to quickly show you one quick way of doing this, and it will help you avoid any rounding errors. If you go back to this line here, I'm just going to highlight it here. We're going to do this part in a different color. There's a quick way of doing it. It's a little bit more advanced for some people, but it makes it very, very easy. We know we've got our surface area is 2 times pi times 5 squared. So you can think of it as 2 times pi times, well, what's 5 squared? That's 25. Plus, over here we've got 2 times pi times 5 times 8. Well, we know that's 40. So if we look back at this again, we've got 2 times pi times 25. Now, if pi was just the letter a, if we just thought of it as algebra, it would be 2 times a times 25. Or if you want, you could say 2 times 25 times a. Well, what's 2 times 25? That gives you 50. So we could say it's 50a. But we're not going to use a. We can just keep using that pi. Okay, if it was algebra, you'd simply use an a there. You'd keep the a. We're going to keep the pi there. So it's pi, pi. So 50 pi. We move over here, we'll do the same thing. You've got 2 times pi times 40. If it was algebra, once again, it would be 2 times 40 with a there or some letter. But we'll just keep using the pi. So 2 times 40 will give you 80. And we keep the pi. Once again, we can add these together because we've got these like terms. So you've got a 50 pi, you've got 80 pi. That's going to give you 130 pi. And we haven't even touched the calculator yet. But we've got our final answer coming up right now. On your calculator, this is simply saying 130 times pi. And if you do that on the calculator, it's going to spit this answer out straight away. You didn't have to worry about these rounding errors, and you'll get the surface area is 408.41 meters squared once again. That's a quick way of doing it. It's a good way to learn. It comes in very, very handy. If you don't like that, just go through this process here like this and just continue to push plus and then place that through. You should get the same answer. If you don't, have a try again. Make sure you don't clear the calculator.